Hello guys. So my name is Chetan from Advocacy Bangalore. So today's topic we are going to discuss is all about the difference between a hub and a switch. So if you talk about a hub, basically hub operates on physical layer, whereas if you talk about a switch, basically switch operates on the data link layer. So what you understand by this is, so if you talk about the OSI model, so basically OSI model was designed basically now to communicate between two different nodes, right? So if you talk about the layers of the OSI, so we have application layer, so we have presentation layer, we have session layer, we have transport layer, we have network layer, we have data link layer, we have the physical layer as well. So if you talk about hub basically works on the bottom layer, that is your physical layer. Whereas if you talk about a switch, it just operates on the upper layer than the physical, that is your data link layer. So if you talk about the second difference between the hub and a switch, hub always performs broadcasting. Whereas if you talk about a switch can also perform broadcasting as well as unicasting as well as the multicasting part. So what you understand about broadcasting is, so let's say, so the PC1 wants to transmit the data towards the PC3. So always whenever the PC1 sends the data, that information will be sent to both PC2 as well as towards the PC3. So this happens when every packet is sent from the PC1 towards the rest of the PCs. So whereas if you talk about a switch basically starts with the broadcasting just to resolve the MAC address with the help of the R protocol, that is the address resolution protocol. So once the switch gets the MAC address, then based on the MAC address, it will perform the unicasting, means we have the one-to-one communication, whereas even your switch will also support the multicasting. So what you understand from multicasting is, it is one-to group, right? So one-to group means, let's say, the PC1 wants to send the data towards only the PC2 and the PC3. So he can send with the help of a protocol called IGMP that is by default enabled on the switches. So if you talk about the third difference between a hub and a switch, so the transmission mode in a hub is half duplex. Whereas if you talk about a switch, the transmission mode by default enabled on the switch is full duplex. So what you understand by half duplex is, so if you talk about a hub, so both way communication is possible, but not simultaneously, not at the same point of time. Whereas if you talk about a switch, so we can have the both way communication, but you can perform the simultaneously part, right? So now if you talk about the fourth difference, so if you talk about the PDU, so which the hub uses is in the form of bits, right? So if you talk about switch, so if you talk about the PDU of a switch, it works based on the frames. So what you understand by PDU is, stands for the protocol data unit. So it tells us the representation of the data. So if you talk about the OSI model again, so if you talk about the first three layers, that is the application, presentation and the session layer, the format is data itself. Whereas if you talk about the transport layer, so it is in the form of segments or datagrams, right? If you talk about the TCP, so the PDU used in TCP, we call it as segments, whereas the PDU used in UDP, we call it as datagrams. So if you talk about the network layer, so the network layer PDU used is in the form of packets. So if you talk about the switch, so we call it as the frames. Whereas if you talk about the hub, we call it as the bits. Now, so if you talk about the next difference, so basically if you talk about the hub, it doesn't offer the spanning tree. If you talk about a switch, basically it offers the spanning tree. So what you understand by this spanning tree is, so basically this is a protocol that is used to what? That is used to avoid loops in the layer 2 technology. So that is not, you can't avoid the loops in the hub, whereas you can avoid the loops with the help of STP in the case of a switch. So again, we have types of STPs, like we have CST, that is common spanning tree, we have per VLAN spanning tree, we have rapid spanning tree protocol, and we have multiple spanning tree protocols. So these all types of protocols is not possible to be implemented on a hub, whereas all these protocols, so all the types of protocols we can implement on a switch, right? So if you talk about the next difference, so if you talk about hub, basically we call this as a single broadcast domain. And if you talk about the collision domains, the number of collision domains on a hub is a single collision domain. So again, if you talk about a switch, again, it also has a single broadcast domain, whereas it has a per port collision domain. So if you talk about the hub and the switch, so what is the difference between the broadcast domains, right? So even the hub is also a single broadcast domain, whereas your switch also has a single broadcast domain. Whereas, so if you talk about the hub doesn't have the flexibility of configuring the VLANs here. Whereas if you talk about a switch, so we can split again the single broadcast domain into multiple broadcast domains, right? So if you talk about a collision domain, so what you understand by collision domain is, basically if you talk about a hub, let's say a PC1 is transmitting the data towards the PC3, and at the same point of time, even the PC2 wants to transmit the data towards the PC3. So since all are in the same collision domain, they are prone to collisions. That's why we don't prefer hub in the production environment. Whereas if you talk about a switch, so even it has per port collision domain. So what you understand by this is, if you talk about the switch ports, there are 3 ports connected, means there are 3 collision domains. Means if, let's say PC1 and PC2 wants to transmit the data at the same point of time, they can do at the same point of time towards the PC3, right? So if you talk about the 7 difference, so basically if you talk about a network hub, it can store something called MAC addresses. So if you talk about the network switch, it can store the MAC address. That's why we call the hub as an intelligent device, whereas a switch as what? If you talk about hub, we call it as a dumb device, whereas switch, we call it as the intelligent device. So what you understand by the dumb device and the intelligent device is, so let's say PC1 is transmitting data towards the PC3, your hub will not understand anything. Means every time a packet reaches towards the hub, it will always perform what? It will always perform the broadcasting part. Whereas if you talk about a switch, so let's say PC1 is transmitting the data towards the PC3. So initially, in order to resolve the the destination MAC, it will just use a R protocol. So once it resolves, then it looks at the CAM table or the MAC address table, and then it will forward the packet based on the unicasting part, right? And then, so if we talk about the speed supported on a hub is up to only the 10 Mbps, right? If we talk about a switch supports speed of 10 to 100 Mbps and 1 to 10 gigabits per second, right? And then if we talk about the final point about the hub is about it has limited ports. Means we can have only 4 to 8 ports in a hub, whereas you can have 24 to 48 ports in a hub, right? So now let's talk about the basic mechanism of a switch, like how the switch works. So if we talk about the basic mechanism of a switch, so let's say the PC1 wants to transmit the data towards the PC3. If we talk about the source IP here, if we talk about the source IP, if we talk about the destination IP, if we talk about the source MAC, and if we talk about the destination MAC. So if we talk about the source IP, so let's say he is my source, and let's say PC3 is my destination, right? So if we talk about the source IP, basically this is 1.1. If we talk about the destination IP, basically it is 1.3. If we talk about the source MAC, so basically it is AA. And basically if we talk about the destination MAC, initially we don't know the destination MAC. So in order to resolve this, the ARP kicks in again. So again, if we talk about the ARP request, again the destination MAC field will be FFFF. So once your PC1 broadcasts the packet towards the switch will again what? The first thing he will do is he will register the source MAC address, and then he will look at the destination MAC. Since the destination MAC is saying to flood, it will do what? It will perform the broadcasting, right? Now, if you see here, so switch, we call it as intelligent because it has something called a CAM table. We call it as content addressable memory. So in the CAM table, or we also call it as the MAC address table. So in the MAC address table, so once the ARP request reaches towards the switch, what switch will do is, so on F0/0, it will register the source MAC, that is AA. Now, he will do a destination, because if you talk about a switch never cares about the source IP and destination IP. Since it is a layer 2 device, so your switch never cares about your source IP and destination IP. It looks only into the frames. So as we said earlier, so only it registers the source MAC and then look at the destination MAC. What destination MAC is saying? You need to flood it out. Means, so one of the copy will be sent to the PC2 and one of the copy will be sent to what? The PC3. Now, once the PC2 receives this packet, he will open the packet and he will check, oh, are you asking for my MAC address? No, I am not 1.3. I am 1.2. I will just what? I will just discard this particular packet, right? So once the PC3 receives this packet, now what PC3 do? Oh, you are looking for my MAC address. What I will do? I'll just send an ARP reply by generating on PC3. If you talk about the PC3's packet flow, if you talk about the source IP, the destination IP, the source MAC, and the destination MAC. If you talk about the source IP, it is 1.3. If you talk about the destination IP, it is 1.1. If you talk about the source MAC, it is CC. And if you talk about the destination MAC, it is A. So again, when the packet reaches toward the switch, again, switch what it will do? It will again store the MAC address on F0/T. So what is the MAC address I'm learning? I'm learning CC. Now we will do a destination MAC lookup where I need to forward the packet. I need to forward the packet to the AA. Now again, the switch has this intelligence. That's why we call switch as an intelligent device, because switch knows where to forward this packet. Again, you will look at the CAM table. Okay, now I want to forward to a AA. I need to forward to which port? I need to forward to F0/0 interface. Means, so your ARP request is always a broadcast, whereas your ARP reply is always a unicast.